In this question, we are given that the function f has a Taylor series about x equal 1, and it converges to f of x for all x in the interval of convergence. And we are given that f of 1 is equal to 1, f of derivative is equal to negative 1 over 2, and then the derivative starting from n equal 2 is given by this functional form. And we need to find the first 4 non-zero terms and the general term of the Taylor series. So we see that the function is 1, the first derivative is negative 1/2, and then let's do second derivative at point 1. Just plug in n equals 2 here. We get negative 1 squared is 1, 2 minus 1, 1 factorial is 1, divided by 2 squared, which is 1/4. F third derivative at 1, again plug in n equals 3 here, negative 1 to the third is negative 1, times 3 minus 1, 2 factorial, 2 factorial is 2, over 2 cubed, which is equal to negative 1 over 4. And so the general term is this for the derivative. So then what we have here, f of x, is equal to f of 1, which is 1, minus 1/2, and then x minus 1, because it's about x equal 1, plus 1/4 times x minus 1 squared over 2 factorial, minus 1 over 4 times x minus 1 cubed over 3 factorial. So these are our first 4 terms. And plus, and so on, plus, and so let's write the derivative, negative 1 to the power n minus 1 factorial over 2 to the power n should be divided also by n factorial, and then plugged in x minus 1 to the power n. So the general term, let's just simplify the general term, will be negative 1 to the power n minus 1 factorial cancels with all the elements of n factorial other than n, so it's going to be 1 over 2 to the power n times n x minus 1 to the power n. So this is our general term. This is our final answer for this part of the question. In this part of the question, we are given that the radius of convergence is 2. So the radius is 2. And we are being asked to find the interval of convergence. So we basically have to check whether the endpoints, and so we have this Taylor series about 1, whether the points negative 1 and 3, whether this series converges. And so let's check x equal to negative 1. In this case, this series is 1 plus 1 plus 1/2 plus 1/3 plus 1/4, and so on. And because this is a harmonic series, and how do we get that? We plug in negative 1 into the equation that we just found in part A. Because this is harmonic series, it diverges. So x equal to negative 1 does not belong to the interval of convergence. And then for x equal to 3, we actually have alternating harmonic series. So it's 1 minus 1 plus 1/2 minus 1/3 plus 1/4 minus, and so on, plus minus plus. So this is alternating harmonic series, and we know it converges. So the interval of convergence is negative 1 less than x less than or equal to 3. So this point does not belong, this point belongs. So this is our final answer. In this question, we are being asked to approximate f of 1.2 with the series, the first three non-zero terms of the alternating series. And so then f of 1.2 is approximately equal to, when we plug in into the first three terms from point A, sub question A here, we'll get 1 minus 1/2 x minus 1 plus 1/4 times x minus 1 squared over 2 factorial, and this is evaluated at x equal to 1.2. And I took these three elements from question A that we had already found. So let's plug this in, 1.2. You get 1 minus 1/2 times 0.2 plus 1/4 times 2, 1/8 times 0.2 squared. And so this is equal to, simplifying, 1 minus 0.2 over 2 is 0.1 plus 0.2 squared is 4 over 100. 4 over 8 is 0.5. 0.5 over 100 is 0.5. So this is 0.9 plus 0.005, which is 905 thousandths. And this is our final answer. In this part of the question, we need to show that the approximation that we just found in part C is within 1/1000th of the exact value. And so because this is alternating series, then the error of the approximation is given by the absolute value of the next term that is not included. And so in this case, f of 1.2 minus the Taylor series of up to the second derivative inclusive 1.2 that we just found is less than or equal to the first term absolute value of the first not included term. And this is from part A, is 1/4 of x minus 1 cubed over 3 factorial. And it had negative sign there, which doesn't matter because we have absolute term, which is equal to, let's plug in the values, will give us 1/4 times 1 over 6 times 0.2 to the third power. And this is equal to, simplifying this, multiplying 1 over 3000, which is less than 1 over 1000, which is exactly equal to what we are being asked to show. So we showed that this difference is less than 1 over 1000. This completes the proof. Thank you, and I will see you in the next video.